Okay, yesterday we talked about the concept of work. Work was equal to force times distance right there. Um, and today what we're going to do is we're going to add in uh, the concept of gravity. And can imagine we start with an object that's on the ground right here. And then we know that it has mass right here. And we were to lift it up uh, a certain distance right there. When we lift it up, it's actually going to take energy and we're going to do work against what we call gravity right there. So if I have a mass and we lift it a distance right there, instead of saying distance, I realize that I'm going to be lifting it up to a height. We know that because this object has mass, it's going to have weight, which is mg. So the minimum force required to lift this object to make it go upward is going to be mg. So the work that we're going to look at is going to be the force, which is the weight of the object, mg, times the distance that we left it, which is height. So now what we're going to end up with is the work required to lift something is going to be equal to its mass times g times h. That work that we do against gravity, lifting an object, causes the object to gain energy. Think about it. If I lift it up, it has the potential to fall. So it's going to have energy in there that's going to store the energy in what we call gravitational potential energy. If we were to look at the formula for measuring gravitational energy, which I just derived right there, we're going to see that the gravitational potential energy will be equal to m times g times h, where m is mass in kilograms, g is acceleration due to gravity, 9.8 meters per second squared, and h is the height that we lifted in meters. I'm going to see that the unit for measuring GPE is going to be also be just like work was a joule. It's also going to be equal to joules for this here. Now I can gain energy by taking a mass and moving it upward. I will gain the same amount of energy going from the floor to the second step would be from this fourth step up to standing on the ledge right there. Each each case gives me a height increase of 0.5, whether it's from the bottom to the second rung or from the fourth rung to the top, tippy top. Oh, and we're going to see that it will gain energy when it's lifted up. The other thing is if it's dropped, it will also lose energy. So let's go ahead and let's try an example problem right here. It says, what is the change in potential energy if I have a mass of 5 kilograms and it's lifted a height of 2 meters up? GPE, that looks like a 6, it's a J, is equal to mgh, which is equal to the mass, which is 5 kilograms, times 9.8, times the height, which we know we lifted it up to 2. This will be 9.8 times 10, which is 98. 98 joules will be the answer for this particular problem here. So when I lift a 5 kilogram mass 2 meters above, GPE equals mgh. 5 times 9.8 times 2 gives me 98 joules. If we want to go ahead and look at this next problem right here. So as an object falls downward, its GPE is going to do this right here. If we look at GPE, it's equal to mgh. The smaller this h, because they're directly proportional to each other, the smaller the GPE has. So by taking an object and making its height go downward like this, it's also going to cause the GPE to decrease. Decrease in height or mass will cause a corresponding decrease in potential energy, gravitational potential energy, of course. Okay, so now what I'm going to do is I'm going to look and I'm going to say that I have a mass and it's going to start up at 2 meters and it's going to drop down to 1.5 meters. Okay, and the mass of an object is equal to 8. So we want to calculate the change in GPE. The change in GPE will be equal to mgh. So it's going to equal 5 times 9.8 times the change in height. Now notice it went from 2 down to 1.5. When I do the difference there, the change in height is just 0.5, which is the difference between 2 to 1.5. If I go and do my math, 5 times 9.8 times 0.5, the answer, hold on, let me check my math, 5 times 9.8. As I was solving the problem, I realized I made a mistake. My mass is not 5, it is 8 kilograms there. So let me try my math again. 8 times 9.8 times 0.5 equals 39.2. So it's going to basically give me a negative answer right there. I'm going to lose about 39 joules, okay? Because the object drops, I'm going to be losing that energy, so the sign is negative right there. If we go ahead and want to look at our next problem right here, I start at a height of, okay, so I have a 10 kilogram object. We know it goes all the way up to 10. It starts at 1 meter high and goes up to 10 meter high. That means it goes up 9 meters. We want to calculate the change in GPE when this mass undergoes an increase of 9 meters. GPE is equal to mgh, which is equal to the mass, which is 10 times 9.8 times 9. If I go 90, which is 9 times 10 times 9.8, I get an answer of, I see an increase of energy of 882 joules. mgh is how I did that. All right, so now we want to calculate the change in height. If we have a mass, and now I know the energy right there, I'm gaining energy right here. So that's going to be the GPE. Oh, that's not that great. If GPE equals mgh, then h will be equal to the change in GPE divided by mg. So it's going to be equal to 16 divided by 2 times 9.8. We do that math. 16 divided by 2 divided by 9.8 gives me an answer of about 0.82. 0.82. So the unit is going to be meters because I'm measuring for height. The unit is meters. Let's see where we're going next here, okay? I believe this is probably the last problem. Yeah, it seems to be. Yep. We'll do one last problem for today and we'll call it quits again. So we want to look at the change in height, and we have a mass, and it's going to lose 20. So it's going to be negative 20 is going to be the GPE because it's losing. So we want to know what's the change in height is. Okay, so the change, sorry about that. The change in height will be equal to the change in GPE over mg, which is equal to negative 20 over 0.5 times 9.8. Excuse my calculation right there. The answer I get is about 4.08, which rounds to 4.1 meters right there. So if we lost energy, the big question will be, did it increase or decrease its height? And the only way keeping the mass the same that I can lose energy is to decrease my height. So the object drops. When it drops, it loses potential energy. When it increases in height, it will gain potential energy. All right, that's all for today. Let's do a quick review. Remember that potential energy is equal to, gravitational potential energy is equal to mgh. It's measured in joules. Remember, a joule is also a kilogram meter squared per second squared, but we just don't like to say all those squares and units, so we make an abbreviation for joules with this right here. The more mass and the more height I have, the more potential energy I have. All right, if you have any questions, reach out. Don't forget to put your attendance into Teams. Thank you. Have a good day.